Greetings and welcome to Totality Town. Although I've moved from the mountains of western North Carolina to the foothills in Colorado, I'm more active than ever observing the sun. Outside of the total solar eclipse in July of this year down in Chile, there's been really little happening on the sun this year. We're basically at solar minimum. For those of you who are new to solar observing, the sun has a cycle of sunspot activity. Sometimes there's lots to see, and sometimes there are hardly any sunspots at all. The basic cycle is approximately 11 years long. That means a little over 5 years from the peak of the solar cycle to the bottom of the solar cycle. As you can see from these animations, the difference between peak activity and minimum solar activity is really noticeable in white light, and it's even more dramatic when seen through a hydrogen alpha solar filter. Right now, we are in what seems to be the quietest of the quiet phases. There's some hope that the next solar cycle will begin soon. And when it does, sunspots will gradually become more common again. The next fun solar event which you can observe, however, is less than a month away. On November 11th of this year, Mercury will transit the sun. So, what's a transit? To put it simply, a transit is when a smaller heavenly object passes in front of a larger heavenly object, but only blocks a tiny part of it. In this case, we will watch Mercury passing directly in front of the sun's disk. Now, if you're wondering about what other planets can do this transit thing, Venus is the only other planet that can pass between us and the sun. Transit of Venus is much more noticeable than for Mercury, because Venus is physically larger and physically closer to Earth. But Venus only transits twice a century, and those have already happened for us. Meanwhile, Mercury transits an average of 13 times a century, and that means we have several more opportunities if you're on the right part of the globe. 2019 will actually be the last transit for North America until May 7th, 2049. To put that into perspective, the U.S. will see 3 total solar eclipses, 4 if you count, far northern Alaska, before we see the next transit of Mercury. Now, in addition to just taking images of the transit, you can also contribute to science. The exact moment that Mercury touches the sun's disk will be different for every location on Earth. And if you can record the exact times for these 4 contacts, you can submit your data to the Alpo transit section. There's a link in the video description. One fun thing to look for is what's known as the black drop effect. It happens when Mercury's disk is just about touching the edge of the sun. For a few brief moments at the beginning and end of the transit, there's going to be a dark bridge between the planet's disk and the limb of the sun. It looks like a black drop of water. Telescope optics are a part, but it's actually not primarily that. It's not even primarily the atmosphere of Earth or the planet. Most of it is due to limb darkening. As you get closer and closer to the sun's edge, it appears darker. Interestingly, transits were the first way astronomers were able to measure the distance between the Earth and the sun. This distance is known as the astronomical unit, or AU for short, and was one of the most important measurements in early modern astronomy. Measuring the relative distances between objects in the solar system was fairly easy, but we couldn't really understand the size and scale of our solar system until we had those distances in miles or kilometers. Sir Edmund Halley of Halley's Comet fame developed the technique, but the next transit of Venus was still over 50 years away when Halley figured this out, and he died before that. And so he never got to use his technique or see anyone else put it in action. The technique is actually very straightforward, even though it has some challenges. All you need is to have multiple observing sites spaced as far apart on the globe as possible. All sites then will take simultaneous images of the transit. We're essentially going to be observing parallax. As most of you are familiar with, parallax is when 2 observers in different locations see the position of an object in different places compared to a distant background. Normally in astronomy, the stars serve as our distant background. In this case, however, the sun's disk is going to be our background, and the location of Mercury's silhouette will shift. The further apart two observers or two sites are, the larger the difference in where they will see Mercury's silhouette. It's going to appear to shift. A few simple measurements from these images will allow us to calculate the length of the AU in miles. Keeping clocks on opposite sides of the globe perfectly synchronized was not really possible back in the 1700s, and so the results weren't as precise as they could have been. Other methods have been developed since then, so we've known the length of the AU for quite a while. But Halley's technique is still sound. I'm leading a national project which will reenact Halley's old technique. The goal of the Citizen Tom project is to measure the length of the astronomical unit completely from scratch by taking measurements during the transit of Mercury this November 11th. The project consists of over a dozen participants of the Citizen Kate project, which collected data during the 2017 total solar eclipse. And that gives us an advantage because our equipment is standardized, making some of the analysis easier. How can you watch the transit of Mercury for yourself? Well, if you own your own telescope with safe solar filter, just look up information on the timing for your location. There are links to NASA's transit page and the Mr. Eclipse website, as well as some other fun info in the video description. If you don't have a telescope, look up your local astronomy club. Most are going to have some kind of viewing event planned for that day. I'll actually be back in North Carolina for the transit, helping Southwestern Community College over in Sylva, North Carolina, with an event for that day, so feel free to come and join us. If there's cloudy weather, keep an eye on NASA. The space-based Solar Dynamic Observatory is going to be broadcasting almost real-time images of the transit. No matter what, the transit's going to be a fun reason to get out and observe the sun in a period where there's really not much else going on for solar activity. So take advantage and go out and enjoy.